Welcome to Study Loop.
All right, so we're looking at free energy changes due to ring flips. So let me recreate these cyclohexane. And the ring flipped form. We add our functional groups: axial chlorine, axial methoxy, equatorial chlorine, equatorial methoxy. Great. And now we've got to look at the delta G value for going from equatorial to axial. Okay. Now, one thing I'll point out here is that what we're doing in this reaction is going from left to right, from axial to equatorial, from axial to equatorial. So if we're interested in finding out the delta G going in this direction, whatever is on that table, we want to take the inverse of it, right? Because the table is telling us this direction. Hopefully that makes sense, right? We want to know what the delta G going from axial to equatorial is, not from equatorial to axial. Okay, so let's look at this table. We're told that chlorine going from equatorial to axial implies a delta G of 0.52. And methoxy going from equatorial to axial implies a delta G naught of 0.75. And that this is telling us is that going axial to equatorial, remember that's what we're doing, gives us a delta G naught of negative 0.52. And axial to equatorial for methoxy is going to give us negative 0.75. And this is all in kcal per mole. Okay, great. So we've got one chlorine going from axial to equatorial. That's negative 0.52. And we've got one methoxy going from axial to equatorial, so plus negative 0.75. Altogether, this is negative 1.27 kcal per mole. That is the delta G of this ring flip. That's option D. Not a very good D, but that's a D. There you go.